in any system, when you have an architecture that we all agree to, when you have a design metaphor that we all find easy to understand, we can build safeguards and security. So I'll give you an example. Imagine if you were concerned about safety on the roads. And we did have those worries 100 years ago. So over time, you create certain standards. So for example, in the US, you drive on the right side of the road, most people anyway. And we have traffic lights, and we have stop signs, and we have behavioral norms. So for example, if a parent and a child want to cross the street at a crossing, you stop. We have school bus laws. So if a school bus in front of you, says stop and flashes red lights, you stop. And these are all behavioral norms. And the reason these behavioral norms help us, and these are standards help us, is because we can look for something awry. So for example, if someone breaks the law, you know that perhaps maybe their eyesight isn't good, or maybe they weren't paying attention, or maybe they were texting, which we know we don't encourage, or maybe that person is malicious, right? The problem with the Internet of Things is we're establishing this new world. We're sort of saying that roads, but we have very few norms. So we don't say drive on the right side of the road. We don't say that's a stop sign. And because of that, everyone's doing or implementing the Internet of Things in their own way. And so it's very hard to detect malice, and it's also hard to put together protection, right? In the road systems, you have police cars, and if you speed, you might get caught. You have cameras. We don't have any of that in the Internet of Things. It's the Wild West. So my own research is directed towards establishing those norms and rules, so that at least you have some orderliness, so that the remnant disorderliness stands out and can be detected. And so in particular, one thing we're promoting is something called the avatar, or the cloud things concept. So the basic idea is we're saying, don't have object A talk to object B. Have object A talk to its cloud avatar of itself. Have object B talk to its cloud avatar of itself, and have the avatars talk to each other. And the reason that works is physical connections between A and B there are many. There are sort of two, n choose 2, sort of n squared combinations. But if you just say, listen, the real object only talks to its avatar, and the avatars talk to each other, we can do a lot of security there, and we can bring to bear all the stuff we know from the World Wide Web, etc. And so that's a clean way to look at the future of the Internet of Things. And strangely enough, that's what Tesla does, that's what Nest does, but unfortunately, right now in implementations, we're a little bit all over the place. About 5 or 6 years ago, I was asked by the then provost of MIT, now president, to help MIT establish a new university in Singapore, the Singapore University of Technology and Design. And I worked with about 150 faculty members at MIT to design this new institution, which has now graduated its first student. It's doing well, it's very inspiring. While I was doing that, MIT did something pretty spectacular, which is it launched this thing called MITx and edX. The basic idea is to use online education to teach not just the 11,000 students at MIT, but perhaps 11 million students worldwide, perhaps 110 million, perhaps a billion. It was an adventurous, crazy, wonderful idea, and it was pioneered by a colleague of mine at MIT by the name of Anant Agarwal. And he and the then provost, Raphael Reif, launched first MITx. The basic idea is students from anywhere can log into MIT and take courses, get graded, get grades automatically. And then over time we spun that out to create something called edX. It was a Harvard and MIT investment. Harvard and MIT invested $30 million each. And then over the course of the last 4 years, it's grown to about 100 member universities, top universities around the world, like Caltech, the Indian Institute of Technology in Mumbai, Tsinghua University in China, Dartmouth, Columbia, who's who of universities now working together. edX is not-for-profit, unlike many for-profit ventures out there. It's also open source, so the edX code is open source. It's a tremendous opportunity to democratize education worldwide. The formation of edX, however, left something of a vacuum at MIT, because now MIT needed its own digital strategy. So I was tapped to become the then director and now vice president for open learning at MIT. And so I have a staff working with me, really amazing people of more than 150 people working on a number of digital offerings that MIT offers, and that is the Office of Digital Learning. And I also craft strategy for MIT in this new space. And the offices include OpenCourseWare, which was MIT's first and at that time sort of stunning and spectacular gift to the world when we gave our curriculum away to the world 15 years ago. It has reached 200 million unique users worldwide. And MITx makes these online courses to be run on edX. I also sit on the board of edX. But since then, we've done a number of other things. We've launched a certificate program called the MITx MicroMasters. It was created right here at MIT. And now there are over 15 universities around the world that have either created or are creating new MicroMasters programs. So it's a program that began here. We have now online professional education, which is something I'm very excited about. The idea is that a professional working at a company can receive online education in big data or in cybersecurity or in the Internet of Things, which is actually a course I created. And we're also going after pre-kindergarten through grade 12 education because that is our pipeline. And MIT has great things to offer there, whether it's Scratch or App Inventor, which have each reached millions of people. But now we're formally doing research in that area. And the final thing is we recently launched something called the MIT Integrated Learning Initiative, where cognitive psychologists, economists, engineers, and scientists work together, management folks work together to look at the future of education and learning as a whole.